Thermoelectric energy. A new wearable device turns the human body into a battery. Researchers at the University of Colorado in Boulder, CU Boulder, have developed a new low-cost portable device that transforms the human body into a biological battery using thermoelectric energy. The device, described in the journal Science Advances, is stretchy enough that you can wear it as a ring, a bracelet, or any other accessory that touches your skin. It also takes advantage of a person's natural heat, using the thermoelectric generators to convert the internal temperature of the body into electricity. In the future, we want to be able to power your portable electronic devices without having to include a battery, said Jai-Liang Chow, lead author of the new paper and associate professor in the Paul Rady Department of Mechanical Engineering at CU Boulder. The concept may sound like something straight out of Matrix movie saga, in which a race of robots have enslaved humans to harvest their precious organic energy. Chow and his colleagues are not that ambitious. Their devices can generate about 1 volt of power for every square centimeter of skin space, less voltage per area than most existing batteries provide, but still enough to power electronic devices such as watches or fitness trackers. Scientists have previously experimented with similar portable thermoelectric devices, but Chow's is elastic, can heal itself when damaged, and is fully recyclable, making it a cleaner alternative to traditional electronics. Every time you use a battery, you're draining it, and eventually you will have to replace it, said Chow. The great thing about our thermoelectric device is that you can use it and it gives you constant power. This is flamboyant high technology. The project is not Chow's first attempt to fusing humans with robots. He and his colleagues previously experimented with the design of electronic skin, wearable devices that look and behave very similar to real human skin. That android epidermis, however, has to be connected to an external power source in order to function. Up to now, the group's latest innovation begins with a base made from a stretchy material called polyimine. The scientists then place a series of thin thermoelectric chips on that base, connecting them with liquid metal wires. The end product looks like a cross between a plastic bracelet and a miniature computer motherboard, or maybe a techie diamond ring. Our design makes the entire system stretchable without putting too much stress on the thermoelectric material, which can be really brittle, he said. Just imagine you're going for a run. As you exercise, your body warms up and the heat radiates into the cool air around you. Our device captures that flow of energy rather than letting it go to waste. Increasing the thermoelectric energy of this device, the scientists added that the device's power can easily be increased by adding more generator blocks. In that sense, he compares its design to a popular children's toy. What I can do is combine these smaller units to get a larger one, he said. It's like putting together a bunch of little Lego pieces to make a bigger structure. It gives you many customization options. The CU Boulder team calculated, for example, that a brisk walker could use a device the size of a typical sports bracelet to generate about 5 volts of electricity, which is more than many watches' batteries can gather. And like electronic skin, the new devices are as tough as biological tissue. If your device breaks, for example, you can put the broken ends together and they'll reseal in just a few minutes. And when you're done with the device, you can dip it in a special solution and it will separate the electronic components and dissolve the polyamine base. Each and every one of these ingredients can be reused. We're trying to make our devices as cheap and reliable as possible, while also having an impact on the environment as close to zero as possible, said Chow. While there are still problems in the design, the scientists believe that the device of his group could appear on the market in 5 to 10 years. Let's hope that the robots and the incipient artificial intelligence don't find out that we, their creators, are a source of thermoelectric energy for them. This is from CU Boulder, and it's on Infinity Explorers by Anne Srivastava. Please leave your comments, and thank you for your support. Kindly support my Patreon account The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.